You build in stone. You build in steel. You carve names into granite and call it eternity. This is the first lie. Solidity is not a state of being. It is a statistical accident, a temporary arrangement of probability that you have mistaken for permanence. Consider the chair beneath you. Consider the floor beneath that. Consider the bedrock beneath the floor and the planetary mantle beneath the bedrock and the iron core beneath all of it. Every layer feels absolute. Every layer is, in fact, a holding pattern, a pause, a long exhale that has not yet finished. The universe is not a vault. It is not a museum holding your monuments for safekeeping behind glass. It is an incinerator running on a long fuse, and the fuse has already been lit. Every object you have ever touched is already on fire. You simply cannot see the flame, because the flame burns on a timescale that makes your civilization, your species, your entire fossil record look like a single flicker in a single frame of a film that has not yet finished. Matter feels permanent because your nervous system cannot perceive numbers larger than a human lifespan. Your senses evolved to track predators, seasons, the rotation of a single planet around a single star. They were never built to track entropy across cosmological epochs. Ask a rock how old it is, and it will not answer because a rock has no concept of time. It has no concept of anything. But the rock is dying. So is the mountain beneath it. So is the planet beneath that. So is every star you have ever called eternal, every constellation you have ever named, every point of light your ancestors used to navigate oceans and tell stories about gods. This is not philosophy. This is a diagnosis, and like any diagnosis, it begins with an examination of the patient's most basic components. Before we can understand how the universe dies, we need to understand what it is made of. We need to go smaller than the atom. We need to find the anchor. At the center of every atom sits a proton. It is the identity card of matter. Change the number of protons in a nucleus, and you change the element itself. Carbon becomes nitrogen. Gold becomes lead. The proton is the signature that defines what a thing is. The difference between oxygen and iron, between water and stone, between a living cell and an inert mineral. Every cell in your body, every grain of sand on every beach, every photon-emitting furnace we call a star, is built on a scaffold of protons holding their charge, holding their identity, holding their shape. The proton is not abstract. It is physically present right now in your bloodstream, in your bones, in the air entering your lungs. There are roughly 10 to the 28th protons in the human body, 10 to the 57th in the sun. The number is not the point. The point is that every single one of them has, until now, been assumed to be permanent. As far as we have ever been able to measure, protons do not decay. They have persisted unbroken since the first fractions of a second after the Big Bang, roughly 13.8 billion years. No experiment, no observation, no detector buried deep underground in a tank of ultra-pure water has ever caught a proton in the act of failing. This stability is the entire reason matter exists in a form coherent enough to assemble into stars, planets, and the biochemical machinery capable of asking questions about its own mortality. The proton's apparent immortality is the foundation stone of every illusion described in Act 1. Solid objects feel permanent because their innermost components have, so far, refused to fail. But so far is doing a great deal of work in that sentence. So far is not a guarantee. So far is simply the longest observation window we have managed to maintain. And theoretical physics has already written the proton's obituary. It has simply not been delivered yet. Grand unified theories, the frameworks that attempt to merge the electromagnetic, weak, and strong nuclear forces into a single coherent structure, predict that the proton is not exempt from decay. It carries within it a fatal flaw, a built-in expiration written into the laws of physics themselves, encoded at energy scales so extreme they cannot be replicated in any laboratory on Earth. The predicted half-life is staggering, somewhere in the neighborhood of 10 to the 34th years. Write it out, a 1 followed by 34 zeros. The current age of the universe is roughly 10 to the 10th years. The predicted half-life of the proton is 24 orders of magnitude longer than the entire history of everything that has ever happened. Every star that has ever burned, every supernova, every civilization that may have risen and fallen anywhere in the observable universe. All of it fits with room to spare inside a single percentage point of the proton's expected lifespan. But the size of the number does not change the verdict. A half-life is not a guarantee of survival until that point. It is a probability. Given a large enough sample of protons, and the entire universe qualifies as a large enough sample, decay events begin almost immediately, just at a rate so low it is statistically invisible across human timescales. Somewhere, right now, in the matter that makes up this analysis, in the matter that makes up you, the clock is already running. The mechanics, when they occur, are clinical. A proton breaks down into a positron and a neutral pion. No warning, no buildup, no structural weakening beforehand. One moment, a proton exists, stable, charged, holding its position in a nucleus. The next moment, it does not. The pion itself is unstable, with a lifespan measured in a fraction of a second, and almost instantly annihilates into a pair of high-energy photons. The positron, the antimatter counterpart to the electron, will eventually encounter an electron of its own and annihilate as well, producing more photons. The result is pure radiation, no residue, no debris, no leftover fragment of proton drifting away to be examined. The particle that anchored an atom, that defined an element, that held a piece of you together for your entire existence, simply ceases to be matter. It becomes light. This is standard model failure at the most fundamental level available to us. A quiet, undetectable, inevitable subatomic betrayal. The brick at the bottom of the wall is not load-bearing forever. It is on a timer, and the timer does not care what is built on top of it. Advance the clock. Forget centuries. Forget millennia. Move past the death of every star you can name, past the death of stars not yet born, past the eventual cessation of star formation across the entire universe as hydrogen reservoirs run dry. Arrive at an era cosmologists call the degenerate era, a period defined not by activity, but by its absence. By this point, the universe has gone dark in the conventional sense. No new stars ignite. What remains are stellar corpses, white dwarfs, the dense leftover cores of stars like our Sun, slowly cooling into black dwarfs as they radiate away their residual heat over trillions of years. Neutron stars, the collapsed remnants of more massive stars, going dark as their surface temperatures drop toward the cosmic background. The occasional black hole, silent, patient, waiting. These objects do not explode. They do not announce their decline with any dramatic event. They simply sit, frozen, dense, and silent, for spans of time that dwarf the current age of the universe by factors so large they lose meaning as numbers and become abstractions. A black dwarf at this stage is, for all practical purposes, a dead object, cold, inert, as close to permanent as anything in the universe has ever been. But proton decay does not pause for cosmic silence. It does not require energy input, stellar activity, or any external trigger. It is a property of the particle itself, written into its structure from the moment of its creation. Inside these dead stellar remnants, protons continue their slow statistical countdown, indifferent to the fact that nothing else in the universe is happening anymore. Across timescales of 10 to the 34th years and beyond, a measurable fraction of the protons inside a black dwarf will undergo decay. The result is a faint, almost imperceptible glow, baryonic matter converting itself into photon gas one particle at a time. The corpse does not rot, it does not crumble, it does not collapse further. It leaks, mass becomes light, slowly, continuously, decay event by decay event, until the object that was once a star, once a furnace fusing hydrogen into helium and powering planets, is no longer a star, no longer even a clearly defined object, but a thinning cloud of escaping radiation, glowing with a light so dim and so cold it would be invisible to any eye, if any eye remained to see it.
Bring the lens home. In the conventional timeline, Earth does not survive the sun's expansion into a red giant. It is likely consumed or rendered uninhabitable long before that. But suppose, for the sake of this analysis, that some configuration of orbital mechanics, some gravitational quirk, allows a planet like Earth to persist as a frozen, dark sphere, ejected or surviving in some distant orbit, drifting through the void long after its star has died. This planet faces the same terminal diagnosis as everything else in the universe. Its oceans, long since frozen solid into kilometers of ice. Its mountains, worn down by billions of years of micrometeorite impact and thermal stress, but still standing. Its crust, its mantle, its iron core, all of it built from baryonic matter, all of it subject to the same proton half-life as every other structure in existence. There is no dramatic event here, no asteroid impact, no explosion, no tidal disruption. The planet does not break apart from external force because by this point in the timeline, there is no external force left to apply. Instead, deep within its frozen mass, individual protons begin to fail, one at a time, scattered randomly throughout the planet's volume. Each failure releases a flash of gamma radiation, a tiny pulse of energy escaping from what was once solid rock, solid ice, solid metal. A single event, imperceptible, but multiply this single event by the planet's full inventory of protons, a number in the range of 10 to the 50th, spread across spans of 10 to the 34th years and beyond, and the picture becomes clear. This is not a single catastrophic failure. It is an erosion at the most fundamental level matter can experience. The Earth does not die in the way a living thing dies. It forgets how to exist. Atom by atom, the mass that constituted Earth converts into a faint outward hiss of radiation, escaping into the surrounding void. The planet simply becomes less dense, less defined, less there, its outline blurring at the edges of what could even be called a boundary, until there is no meaningful structure left to call a planet at all. Just a diffuse, cooling shell of decay products expanding outward, indistinguishable from the background.
Humanity has always sought permanence through artifact, monuments designed to outlast empires, records etched into stone, printed onto paper, encoded onto discs, messages sent outward on golden plaques attached to spacecraft drifting beyond the solar system, intended to outlast the species that made them, intended to prove to whatever might find them that something once lived here, once thought, once built, once wondered what else might be out there. Proton decay renders this ambition void, not difficult, not unlikely, void. Every fossil embedded in sedimentary rock is made of baryonic matter, the calcium of bone, the carbon of soft tissue replaced by mineral over geological time. Every golden record drifting through interstellar space etched with diagrams of human anatomy, recordings of human languages, images of human life, is made of baryonic matter. Every atom that once formed a human brain, a human thought, a human memory, every synapse, every neuron, every molecule of every neurotransmitter that ever carried a signal is made of baryonic matter. None of it is exempt. There is no special category of important matter that decays more slowly. A proton inside a fossilized femur and a proton inside a grain of interstellar dust are, to the laws of physics, identical.
The same decay process unmaking stars and planets unmakes evidence. It does not distinguish between a mountain range and a message. Across timescales of 10 to the 34th years and far beyond, the physical record of biological existence does not get buried deeper, does not get lost in some unexplored archive, does not get destroyed by some external catastrophe that a more careful species might have prevented. It dissolves from the inside, proton by proton, into photons and leptons indistinguishable from the radiation produced by dead stars and dead planets. The signal and the noise become the same thing. The universe does not need to erase history. It does not need to make a decision about what to keep and what to discard. It simply waits for the substrate of history, the matter itself, to fail on its own. Given enough time, there will be no archive left to search, and no searcher left to search it, and no difference between the place where a civilization once stood and the empty space around it. As ordinary matter converts into radiation across the universe, a strange hierarchy emerges. Black holes, the objects once considered the most destructive structures in existence, the things that civilizations once feared as cosmic predators, become, briefly, the only structures left standing. Everything else, every star, every planet, every fossil, every golden record, has dissolved into a thin gas of photons and leptons. The black holes remain. They remain because they are immune to proton decay in the conventional sense. Nothing crosses their event horizons to undergo the process in any observable way from the outside. Whatever happens to matter once it falls past the horizon is, for the purposes of this analysis, irrelevant. From the outside, a black hole is not matter in the way a planet is matter. It is a region of space-time defined by mass, charge, and rotation, and proton decay has no purchase on geometry. But immunity is not immortality. Black holes bleed, slowly, through a process called Hawking radiation, a quantum mechanical effect by which a black hole emits particles near its event horizon and gradually loses mass over time. The smaller the black hole, the faster this process occurs. The larger the black hole, the slower. The timescale for this evaporation is almost incomprehensibly longer than proton decay. While baryonic matter across the universe converts to radiation across roughly 10 to the 34th years, the largest black holes, the supermassive giants that once sat at the centers of galaxies, require timescales on the order of 10 to the 100th years or more to fully evaporate. 10 to the 100, a number so large that 10 to the 34th, the number that governs the death of all ordinary matter, looks, by comparison, almost immediate. The contrast is stark and worth sitting with. The fast, comparatively sudden dissolution of all conventional matter, every star, every planet, every fossil, every memory, completed in a span of time that is itself almost incomprehensible, followed by an almost static, glacial bleed-out of the last gravitational structures in existence, a period so long that the previous era, the era of matter, the entire history of stars and planets and life, becomes a rounding error within it. For a span of time so vast it cannot be meaningfully compared to anything in human experience, the universe consists of nothing but evaporating black holes, drifting alone in an expanding, cooling, increasingly empty void, each one a slowly closing wound in space-time, each one the last remaining evidence that structure of any kind ever existed. Eventually, even the black holes finish evaporating. The last one, whichever it is, releases its final burst of radiation, and with it, the last gravitationally bound structure in the universe ceases to exist. What remains is the dark era, a universe filled with nothing but a thin, freezing gas of photons, neutrinos, electrons, and positrons spread so far apart by the continued expansion of space that meaningful interaction becomes statistically impossible. Two particles, drifting in the same general direction, separated by distances so vast that the time required for them to ever meet exceeds any timescale discussed so far. Temperatures approach absolute zero. Density approaches zero. Structure, in any sense the word has ever meant, organization, pattern, form, boundary, ceases to exist. Look back at the beginning of this analysis. Solidity, permanence, the feeling of one object resting against another, of a hand closing around something and holding it, the weight of a stone in your palm, the temperature of another body next to yours. These were never properties of the universe. They were temporary side effects of a chemistry that depended on protons remaining intact long enough for atoms to form, for molecules to bond, for stars to burn, for planets to cool, for biology to occur, for someone, somewhere, to believe, briefly, that matter was forever. It was not. Matter was a mistake, and the universe has finally corrected it.